Hi. Okay, today we are going to learn about grade 8 number systems. Okay. So first on our topic, it will be integers. Okay. So now, what is an integer? So when we talk about an integer, we are talking about, for example, a number that is not a fraction. So we are talking about a whole number that can be either positive or negative, and that includes a zero. Okay. So, for example, any number that you see on a number line, we can call it an integer. So we have zero, then we have negative numbers, -1, -2, -3, and this number line continues. Then we have a +1, +2, +3, and the number line increases. Okay, so we consider these numbers as integers. So integers, we are talking about the whole numbers that can be positive and negative, and that includes a zero. Okay, so now inside integers, we have whole numbers. Okay, from integers, we have what we call whole numbers. Now, what are whole numbers? Whole numbers are all natural numbers, including a zero. Okay, so I'm going to show you on the number line all numbers from this point up to positive infinity. We call them whole numbers. So from zero, counting positively, these are whole numbers. Okay, then inside whole numbers, we have what we call natural numbers. Now, natural numbers are all counting numbers. Okay, natural numbers are all numbers from 1 until infinity. So the difference between whole numbers and natural numbers, it is this zero. So natural numbers does not include zero. So natural numbers does not include zero. But when we talk about whole numbers, we talk about all natural numbers, including zero. Including zero. During S0. So when you have to define your natural numbers, we talk about counting numbers. When you have to define whole numbers, they are all counting numbers include zero. Then when you talk about integers, you are talking about all negative and positive numbers, including a zero. That is your integer. For example, when you deal with functions and you draw up a Cartesian plane, you are dealing with integers because you draw a Cartesian plane from negative towards the positive, from negative y towards the positive y. Okay, so that is an example of our integer. Now let us explore more of the types of numbers. Okay, Now, we have what we call a rational number. Okay, we have what we call a rational number. Now, you have to ask yourself, what is it that you can call a rational number? Now, rational numbers are all numbers that can be written in a form of a fraction. Okay? Rational numbers. So, rational numbers, we talk about any number that can be written as a fraction, for example, a over b. Those are our rational numbers. Okay? So there is an exception. You must make sure that b is not equal to 0. Because any number divided by 0 does not exist. It's not possible. Okay? So rational numbers are numbers that can be written as what? A over b. Now, since we have rational numbers, you must ask yourself, what is an irrational number? Okay. Now, you can take a guess. An irrational number will be an opposite uh, of a rational number. So both rational numbers and irrational numbers, they are what we call a real numbers. They are on the real number system. But now, irrational number cannot be written as A over B. So this one cannot be written as a fraction. So this one cannot be written as what? A over B. For example, e.g., press your calculator and check what is the square root of 2. Okay. Now, if you press the square root of 2, you cannot write this number as a fraction. Okay. Now, for example, check pi. Press pi on a calculator. Okay. So those are the things that you need to know about irrational numbers. All right. Now let us talk about what we mean about a real number. Because I've explained integers, I've explained whole numbers, I've explained natural numbers, rational numbers, and irrational numbers. Now, let me add a new page. Okay. Now, for example, earlier, when I was explaining a rational number, I said the rational number is a number that can be written as A over B. Okay. Now, when you talk about a real number, A real number includes both rational and irrational numbers. Okay. For example, if you take any number, right now we're talking about real numbers, okay? If you take any number, for example, A divided by B, where B is not equals to 0, it qualifies as a real number. But now, let's say B is equals to 0. Let's assume that your B is indeed equals to 0. Now take any number. For example, let's say A is equals to 2 and B is equals to 0. Press it on your calculator and see what you're going to get. So any number, be it 100, be it 200, be it 1000, any number you divide by 0 doesn't exist. Okay, so it is not a real number. So it may be a decimal that cannot be written as a fraction, but it's still a real number as long as you are not dividing any number by 0. You understand? And again, as long as you don't take a square root of a negative number. You understand? Even this one is not a real number. In higher grades, they call it something like imaginary number. For your syllabus, real numbers does not include a square root of a negative number. A cube root of a negative number exists, but a square root of a negative number does not exist. So this is how you can claim it. If your set or your square root has a positive number here, then this number inside cannot be negative. But if your root has an odd number here, then this number can be negative. If it has an even number here, it cannot be negative. It has to be positive. But if it has an odd number here on the root, then the number inside the root can be a negative number and it will be valid. Okay? Now, all numbers that you use in your class, they're all considered real numbers because when you press your calculator, they do exist. All right. Now, I'm going to make use of these number systems to try and explain other topics. For example, you are going to solve for X, then you will see. I will ask you to identify, is this number a real number? Is it a rational number? Or identify any category it falls under. Okay? So now, let me add a page. Okay. Now let me grab a question for you. Okay, now let's say you have okay, now I have just extracted this question from a 2015 ANA exam. Okay, so from this question paper, we are going to start from the very first question. They say consider the expression of 7x squared plus 5x plus 4. Then answer the following questions that follow. All right. Write down the constant term. When we talk about a constant term, we're talking about a term that does not include a variable. And a variable in this case is x. So the only term that does not include x is 4. Okay. Now, what is the degree of the expression? When we're talking about degree, we check the highest exponent of x. Okay. Now, this expression, it is of a degree 2 because the highest exponent of x is squared. Okay. Now, it is of the second degree. Okay. It is of the second degree. Or you can say degree 2 because that is the highest exponent of x. Write down the coefficient of the second term. When you talk about coefficient, for example, if you talk about 7x squared, this we call an exponent. This is our variable and also a base to the exponent. This is called what? A coefficient. So the coefficient of the second term is what? Is the middle one, which is 5. So the number before the variable is called the coefficient. Okay, now calculate the value of the expression, this expression, if x is equal to -1. Now, since x is equal to -1, where you see x, we substitute with -1. Then there is a square there, plus 5 into -1, plus 4. Okay. Now this equation will give us what? 1 squared will be +1. 7 will remain. 5 times -1 will be -5 plus +4. Now 7 minus 5 is 2. 2 plus 4 is 6. Okay. Now the answer to this is 6. All right. Now, but on this expression, you must consider what we call BODMAS. So BODMAS says bracket, order, division, multiplication, addition, and subtraction. So subtraction comes the least. Okay. So those are the things that you must also consider when you deal with your expressions. All right. Now, since we must consider the, what do you call, the addition first, you must consider these two terms before the 7. All right. Now let's continue to 5.2. 5.2 says simplify the expression 2x minus 3y plus 4 minus 3x minus y minus 2. So now when you simplify expressions, you must isolate terms. What do I mean about isolate terms? You group them into the like terms. You put the terms that contains a y on one side. You put the terms that contains x on other side. Okay. Now let me show you. Now we have 2x. Okay. But there's another term that contains x, which is -3x. So any number that you take it with the sign before itself. Okay. Now I've written all the terms that contains x. And I'm going to all the terms that contains y. The first one is -3y. So I said all terms, they go hand in hand with the signs before them. Then we can see another term of y, which is negative y. Okay, now I have plus 4 minus 2. Now these two are like terms because they both contain x. 2 minus 3 is negative 1, so I'm going to have negative x, because when 1 is the coefficient, you don't write it. Negative 3 minus 1. So it's going to be negative 4y. Okay. Now, positive 4 minus 2, it will be positive 2. Okay. Now, I hope you understand the concept of adding negative numbers. For example, on a number line, sorry about that. On a number line, and my line is not straight. It's a little bit better. Now, on a number line, if I have a -1, -2, -3, -4, -5. Okay, then hit 0, 1, 2, just like that. Now, this is a basic rule. When you add, you go to the right. When you subtract, you go to the left. So we had negative 3y. Then it said -1. When it says -1, you jump 1 unit to your left. You understand? Hence, -3 -1, they give us negative 4y on the previous page here. Hence, they give us negative 4y here. Okay? So that's how you calculate your negative numbers. You go to the number line, every time you subtract, whether you subtract positive numbers or negative numbers, every time you subtract, you go to the left of the number line. Every time you add, you go to the right of your number line. Okay? Let me go to a new page. All right. Okay. So remember, every time we calculate and write numbers, remember to identify your numbers as whether they fall under natural numbers. Is it a whole number? Is it an integer? Is it a real? Is it rational or irrational? Okay. So that you can get used to your number systems. Fine. Now we got ourselves into this page when it says calculate. Now we are given 4x plus 3 minus 3x minus 2. So this takes us to the BODMAS, what I told you before. Now, since you can see there's a brackets there, you solve the brackets first, because that's what BODMAS says. It's spelled as BODMAS. Okay. It says bracket, order, division, multiplication, addition, then subtraction. Okay. Now let's start with the brackets. We have a negative into 3x minus 2. Now we do this and we do that. So minus 3x plus 2. All right. When negative multiplies by the positive 3x, it will become a negative 3x. Now, when this negative multiplies by this positive here, it becomes positive 2x. Now that I've solved the brackets, I rewrite the full expression. So I'm going to back to the original expression, 4x plus 3 minus 3x plus 2. Okay, now I calculate. What did I say on the previous page? When you see unlike terms, you group the like terms. So 4x minus 3x, you are going to be left with x after grouping like terms. Okay, so let me group them. I'll not take shortcuts. So 4x minus 3x plus 3, okay, plus 3 plus 2. Now 4x minus 3x, you are going to be left with x, 3 plus 2 plus 5. Now this becomes your final answer. Okay, now 5.3.2, you are given 18x squared minus 12x minus 6. Okay, now whenever you're asked to calculate a number like this, my advice to you is separate the terms from the fraction. How do you do that? Easy peasy. Okay, now from this equation here, I'm going to write each term divided by the denominator. So 18x squared will be 18x squared over 6 minus, I write the sign of 12, then 12x divided by 6, then minus 6 over 6. Okay, now 18 divided by 6 is 3. So I'm going to be left with 3x squared minus 12 divided by 6 is equals to 2. Then x also is there. Then 6 divided by 6 is equals to 1. Now, this is our equation. Okay? So this is the final equation. They didn't say solve for x. They said calculate. Okay? This will be your final answer. But if they said solve for x, maybe they were going to equate this thing to 0 or something like that. Now, your equation have reached its final answer. Let us continue to 5.4. Now, 5.4, complete the simplification steps below. Okay. Let's say complete the simplification steps below. Now, if you're to simplify, multiply these two. So 2 times 3 is equals to 6. Y times y squared is equals to y cubed. Minus, they wrote it for you. 14 times 1 is 14. Y times y squared is y cubed. So 6 minus 14, it's negative 8y cubed. Then there's a negative there because it was given. That is your final answer. So for getting this one, you get a mark. For getting this one, you get a mark. For your final answer, you get a mark. Okay? Now solve for x in each of the following equation. Solve for x here. All right? So I will give you that one as a homework. Let me minimize. Okay. We come back there. Okay. Now we've reached the end of our video, but I wanted to give you a homework. So yes. This is your homework, this page. All right. So you can see it. This is your homework. All right. Cheers, guys.